So this is a recording to make up for the recording in class that failed, unfortunately. So I'm just doing a quick lesson of what I taught today in my higher algebra class, first day of the second semester. So I'm going to try to show you how to find the degree of a polynomial, and we'll evaluate polynomials, and we'll add and subtract polynomials. So first off, what the heck is a polynomial? Well, I know you can read, so you can read that definition. Basically, they usually look something like this. And they have different degrees on different terms. And that, for instance, is a degree 3, and it's got 4 terms. Now, none of these are like terms, which means I can't add any of them together. But if, for instance, this had had a squared on it, we could have put these two terms together because they would have been called like terms. All right, but there wasn't a squared here, so that is a degree 3 polynomial. Now, to decide if something's not a polynomial, that's if you have weird powers, like a negative power. That makes something not a polynomial. Or if it has a fraction power, like to the 2/3 power. Those are, you know, like they make real things, but they're not polynomials if they have fraction powers or negative powers. So, again, these are both polynomials. This one's a trinomial because it's got 3 terms. This one's got 1, 2, 3, 4, 5, 6, 7 terms, and none of them had the same degree, and so none of them are like terms. Notice there aren't any fractions with variables or negative exponents. And that also applies to, you can't have a fraction like in front of it, like 1/5. They have to be whole numbers to be a polynomial. So let's move on. The degree of a polynomial, basically this one's degree is 2 because you take the biggest power that it has. This one was only a power of 1 and this one's 2, and that's the degree. So if the thing isn't multiplied out yet, which we'll do more of this tomorrow, then you'd have to multiply it all out and see what the biggest degree is. In this case, when you do the x times the x, you'd have an x squared. That would be also a degree 2 polynomial. So when they're all multiplied out, it's just the biggest degree. Next, to put it in standard form, this one's not in standard form because the biggest degree here should be, oh wait, no, this is even bigger. The biggest degree should be in the front, and then they should be in what are called descending order. So to the 6th, then to the 3rd, then to the 2nd. So they need to be in descending order. This term here that doesn't have an x on it, that's called the constant. Now to evaluate a polynomial, you're just going to take a number, like, so for instance in this case 3, and you're going to put it into the polynomial where the x is. So I always put it in where the x was, and I put a little empty parenthesis where the x was. Notice empty parentheses, because without those parentheses, you'd actually get a different answer. So trust me, replace the variable with an empty parenthesis and then drop in the number. You will be able to use a calculator on this, so that 3 to the 3rd, even though it's kind of hard to do in your head, 3 times 3 times 3, it can be done. 3 times 3 is 9, times 3 is 27. But then 3 times 27 is kind of a pain. Again, you'll have a calculator. And from here, I totally would just let you use a calculator to simplify it down. That is called evaluating an expression. All right, so if I wanted to find f of negative 2, I'm just going to make an empty parenthesis wherever there was an x. And then inside all those empty parentheses, I would put a negative 2. This is called evaluating the function at negative 2. And then this, negative 2 to the 6th, definitely want a calculator, otherwise you got to go 2 times 2 times 2 times 2 times 2 times 2. And that's a pain, big number. All right, and when it's negative, got to be careful with that. You just multiplied 6 negatives together. And when it's an even number, that comes out positive. So if you're going to find f of 4 here, wouldn't you just put in a 4 here and here and here? Yeah, but you'd want to put it in parentheses. If you're adding and subtracting polynomials, the cool part about this kind is you can just drop the parentheses. It's just like they're not even there. And then you go and say, oh, what would regular x and negative 7x make when I put them together? Negative 6x. What would the 5x to the third and the 2x to the third make? 7x to the third. And what would the negative 6x squared? And interesting, there aren't any other x squareds. Well, then you just write negative 6x squared. And then last but not least, we have this plus 3 here, which there's no other whole number to go with it, no like term. So then I just put plus 3. And there you go. There's my polynomial. And I even wrote it in order with the biggest power first, and the second biggest, and the third biggest, etc. Okay, so there's the basics of how you have to add them when they have parentheses around them. You can just act like the parentheses aren't even there. And here, with the negative, I'm going to call it a negative 1. I have to think of this as like I can distribute this negative 1 to all three of those. And then I'll have negative 2x to the third plus 6x squared minus 5. And that can now be combined with this part where, since there was no negative in front of their parentheses, those parentheses here and here, they can be dropped. So then I'm at 3x to the third goes with the negative 2x to the third, and that makes 1x to the third. Negative 9x squared and positive 6x squared makes negative 3x squared. And then I have this 4x, which doesn't have any other 1 to go with it, so I just say plus 4x. And then last but not least is my negative 5 here, which there's no other whole number that goes with that, so I just put minus 5. And there is my polynomial. Notice I wrote it with the biggest power first, so that's a degree of 3, and it's a 4-term polynomial. If any of these powers had been negative, then it wouldn't have been a polynomial anymore. And if any of these powers had been fractions, like say this had been 3 over 2 power, then it wouldn't have been a polynomial. All right, so that's it. And now all you have to do is go to your Schoology quiz. The first question, if you're doing the right one, is going to ask you about when you have negatives or exponents in the powers, is it a polynomial or not? You'll know you're in the right quiz if that's the gist of the first question. And that's all I have for you for the video for the first day of the second semester in higher algebra.